Hey, how's it going?
Hey.
How's it going, everyone? Welcome to our live stream, and today we're talking about MATLAB basics. Very exciting. My name's Heather Gorr, and I'm joined by Elsie.
Hi, I'm Elsie Eigerman.
And basically, we'll give a little bit of an introduction in case you haven't met us before. I am a product marketing manager for the MATLAB team, and I work a lot on making videos and demos and helping people get started, helping people integrate MATLAB and Python code, and a lot of deep learning, AI kind of stuff. My PhD was in physics, and I did a lot of machine learning in that time, well, before it was cool. So Elsie, would you like to introduce yourself?
Hi, I'm Elsie. I'm a technical video producer here at MathWorks. So I assist great people like Heather in making videos. My background is in more of a data science type field. That was what my undergraduate degree is in. And I'm excited to be here.
Awesome. All right. Fun fact, our very first live stream was the two of us.
Yeah.
So the very first MATLAB live stream. We're the OG live stream crew right here.
Yeah, excited to be back.
Awesome. So make sure, we really want this to be interactive. Also, I'll go back because make sure you keep in touch if you think of something later that you didn't ask during the stream. But we really want to make this as interactive as possible. We'll answer your questions and really help you get started, find out how to get started. Basically just try it, that's the secret. And then a lot of the things that you need to think about as you're using MATLAB, how this stuff works, basically. And that'll kind of lead right into, Elsie was saying quirks, and I was like, you're probably going to mess this stuff up, especially coming from different languages, So kind of those pointers and things to keep in mind. And then, of course, finding out lots more, and whatever you would like to learn along the way. All right, shall we? That's it. I got one slide.
Let's jump into it.
Let's do it.
Let's start messing around in MATLAB and seeing what happens.
So honestly, the best way to get started is just do it. So I know everyone's different, but there are, many of us, I guess, lots of scientists, engineers, very smart people use MATLAB. So I say try it and figure it out, right? So one of the best places to start is the MathWorks website because there's a slew of documentation, really amazing examples, and that's really kind of the most practical ways to get started. Someone's trying to solve a problem, go to the documentation, find an example that looks like what you want to do, and then substitute your code or your problems or your data.
And I hear we can start doing examples in browser now.
Exactly. It's very exciting. So I just went to the MATLAB documentation. It's just mathworks.com help. And if you sort, you can go to the examples. And so I'm dyslexic. I don't read well. I don't read good. So I like to do math. That's part of the magic for me. So we want to take a look at, just the examples. So we'll go step by step trying to solve a problem. All right, what shall we do here? Data?
Let's do data. Data's fun.
Lots of people need to analyze data. I think so. I think that's a good one. All right.
It's all around us.
Pre-processing. It is. And again, no matter whether you're making it up, if you're simulating it, or if you have it in a file or on the cloud or whatever, you often have to deal with data. So let's go with, I like this one, using live editor tasks, because it also helps kind of lead into some of the philosophy that we were talking about. So, sure enough, I could just try this example. Cool. So, you might think maybe the first thing I need to do is to download something or install or do whatever, but you don't actually. You can just run it right in the browser. You don't even need to have a MathWorks account. If you do happen to have MATLAB, I'm not sure why this wasn't logging in for me. That's always fun because obviously since we're live, that's probably why. So let me log in and show you. Ooh, look at that. Now because I have a MathWorks account, I can open it in MATLAB Online. So now I get the full-on experience. So again, this makes it really easy to just get started. You always have the most recent version. But so we also get a lot of people that are like, oh, I have MATLAB like 1972 or something, or whatever, installed. And this always is going to be the latest and greatest release. And again, you'll see this is, regular full-on MATLAB. I was just using this like half an hour ago in a different webinar, so it looks maybe a little different than yours. But, same kind of thing, it's just in your web browser. And so as you can see, here's my example. I'm gonna add a section. I'm just gonna run this first section. So one of the things, also let me get back to the regular layout. So this is the current folder, just kind of giving everybody accustomed to what we're seeing. This is where we are located in, our path.
So is this on our machine or on the, what's it called, MATLAB Drive?
Yeah, so MATLAB Drive, good point. That's actually sort of your mechanism to share your files and, work kind of in between your desktop MATLAB and MATLAB Online. And so you'll see, the examples pop up right in MATLAB Drive, but if you notice, these are Baby Yoda, AI music. Let's see, I got lots of good stuff here. From Cleve, Intro to MATLAB, workshops, music class, all sorts of stuff. And so it's kind of like a Dropboxy kind of thing where you can access that anywhere. And this is where your examples live. We can get back to it. Also, I could have just used this little button, but just so you're aware. And I believe it was this one.
Yeah,
Very
that seems
good.
about right.
And we're back. So a couple things here. Again, you'll find most of what you need on this tool strip, right? So, you can kind of be brave, poke around, try some stuff. That's one thing that's really nice about the world we live in. You don't have to just look at a blinking cursor. So that's the first step. And also, whenever you're running these, you can run section by section. You can run in advance, or you can run everything, that big green play button. So again, just trying to orient you if you're following along. And another thing that we want to, I like this example because it actually immediately starts talking about some of the fundamental ways that MATLAB is organized. Everything is a vector or a matrix, right? So if you notice here, we have a 1 by 100 double precision, that's the default. But even if I said, all right, that's a 1 by 11. Let's see. We have a 1 by 1. So always something to keep in mind. MATLAB is array-based, vectorized. You want me to hear that again? And everything is kind of thought of as an array. Also, I like this because it shows you immediately the ways that you can make arrays. So this is going to make, x is equal, I just overwrote x. Whatever. X is equal.
We'll just run it again.
We'll run it again. It's no big deal. This is what we do.
It.
This is part of the beauty of getting started.
Yeah.
You know what to do. So x is equal to 1 colon 100. So the colon operator is basically the range operator. And so this is going to give, starting at 1, ending at 100, every, digit between. So that's an easy way to do that. And again, I made x equals 42 instead, but no big deal. I can just run that again. Cool. So also I liked to point out, here there's a semicolon. You don't need the semicolon. It's not a must-have in MATLAB, but it does indicate end of line, just like C or, Java? I don't remember now. But C, definitely.
Java as well.
Yeah, okay. I try to forget as much as I can.
Each language has its own little quirks. And
exactly.
The best is that professors switch between which languages to use, so,
Mid-sentence sometimes. So the semicolon will suppress the output. So just something to keep in mind. If I used semicolon, I would have gotten no output. Also, since that was a fun trick, I just hit the up arrow and it goes back through my command history. So you can use up and down for that. So the other thing is I like this, again, in this example, because it really shows how math works. Get it? The math works.
I sure hope it does.
Yeah, it does. Trust me, we have lots of unit tests for that. So Very typical kinds of math syntax, okay? Just multiply, divide, those kinds of things. And once we have a vector, we have this, 1 through 100, we can just pass it right in. So here it's just in this equation. Pretty straightforward, that's one of the nice things. It's really mathy.
And so the operations are done to each element in the array in that
Exactly. Line? Yep, exactly. And so that's one of the things to keep in mind too. This has changed over the years, but generally you want, if I was like say adding x plus y, I would need x and y to be the same, size, the same orientation. So we'll see this as we go along, but something to keep in mind because otherwise it would give you an error. Mm-hmm. Then also here we're using not a number. So nan is not a number, and that's a way to represent sort of an empty space. You see this a lot with importing data. If you have an empty cell in an Excel file, let's say, it'll bring in as not a number. So here we're just adding some for fun, for sake of example, and changing a couple of the data points. All right, and so again, one of the reasons I like this is because it really shows a lot of the things that I tend to value, or lots of people will value about MATLAB, which is this kind of in-between world where you're using apps, using interactive tools, trying to visualize your data, explore, and then you can also generate the code, and you can keep it all in one place. So here we're using a live editor task for creating a plot. And I just wanted to show, there's quite a few of these. I'm sure we'll show a few more as we go along. But, a lot of those kind of typical data science things where, you have to clean up missing data, smooth, normalize, those things that you need to do over and over again, and you might not know the best method. So these are nice little apps that you can kind of stick right in your script.
And it's great because you don't have to remember what specific word gets you a bar chart versus a line chart and so on and so forth.
Exactly.
You can just click a button.
Exactly.
If I wanted to see like the data set that we created, is there a way that I could see it as a spreadsheet?
Absolutely. So if you take a look, I keep double clicking to minimize that, just by the way, in case you're just getting familiar. But if you look at the workspace, this is all the data that we have access to in MATLAB. So if I just double click on that, I think I did, very good. That opens up the variable editor, and it'll basically just kind of like a spreadsheet. You can actually work with it like a spreadsheet too. You could replace the numbers, you could do some minimal equation stuff, but that's a great way to visualize. Also, you could even just explore from here, right? So there's the tabs at the top. You'll see, there's apps that you could use. Here I selected that first line, and we could, pull up some kind of plot. Let's see what we got here. Oh, that wasn't very fun. Let's do it again. I like comment. That's a fun one usually. All right, let's try again. This is good because we're learning about all the different things that you could click on. All right, here we go. So Comet just kind of goes line by line. It's like a little animation of your plot. So I think it's
very fun.
I think it's pretty fun. But that's the idea. You can select your data, you can play around, you can experiment, things that you might not have thought of, different ways to visualize. And if you notice, it actually showed it on the command line. And so it's kind of what we're talking about, that philosophy of, being able to click around, try some stuff, explore, and then, have the code there whenever you're ready to, incorporate that into a script, or, if that made sense to you.
You can just copy paste that code there right into your live script. You got it.
Done. Let's do it. Yeah. There we go. Perfect. All right, so that was kind of the first sort of crash course there. Here's another, since we added those nans, let me get rid of this. But this is just more of examples of the live editor tasks. So for example, that missing data, those not a numbers, how do I want to fill those, right? Geez, do we want p-chip or modified Akuma cubic interpolation? I like Makima. And so this actually lets you, explore, visualize immediately, see which ones are being filled. Maybe let's try a different one. Looks pretty good to me. And then these also have the code too, if you prefer. All right, similar kind of idea here with outliers and smoothing. Again, I like to point these things out just because these are, not always straightforward. And even if you're, taking a course on, data science or whatever, you might be learning about these things, but you can still try it out with your code or your data, itself. All right, any questions so far?
I'm not seeing any questions. People are very happy to be here, which is nice.
All right, very good. We're happy to be here too. All right, cool. So let's, I think I'll go into my MATLAB now. I have a local MATLab.
Oh, we have a question.
Yes.
About operating systems. I know you love operating systems.
I do. So
what OSs is MATLAB compatible with?
That's a great question. There is a full list of all of the different Linux flavors and things in the documentation, but basically Windows, Linux, Mac. Yeah. Usually it's the most common Linux flavors like Ubuntu, Red Hat, like the more professional ones, and most likely the last release of those, usually within a couple of months of the most recent release of Ubuntu or Linux. So yeah.
Is MATLAB good for circuit design?
Good question. Yeah, I think there are quite a few people that use, I think a lot of people will use Simulink for that because, not only will you design the circuit, or you could even import your designs from a different, program, but then you can simulate what's going on with your circuit. So you can add in, there were, I guess was it last week? There was a Simulink fundamentals or intro to Simulink. So that would be a good one to check out to see, what kind of opportunities you have there. So the simulation part, I think, is really the most valuable part of circuit design in MATLAB. Yeah, good. Keep coming. All right, so I guess I will also show, some of these other, I think the documentation is pretty much the place to go. Anytime, you have questions for things, of course, YouTube is a great place to go too. But, generally you look at the MATLAB documentation, right? And so just, since somebody was asking about the...
I'm getting a compliment on my glasses in the chat.
Elsie's glasses.
So I was showing off that they're magnetic.
Yeah, I also complimented them right before we started. I also appreciate those. Excellent. Yeah, so if you were interested in the circuit design or aerospace, I think somebody had asked about, you can always go to the documentation and start from there and get some examples and get some good info, based on what you want to do. All right. So I think I will go to, let's find another example, shall we? All right. What do you think?
I don't know. I feel like image processing is fun.
It is.
Then you get to see pictures.
That's true. That is true. All right. We'll do another of these. So I wanted to just show a couple of, mostly I wanted to show the apps. So I wanted to show some, we saw some good stuff here, but I wanted to really, take advantage of, especially since we're talking about the basics. So we spend a lot of time making it really easy for you to get started, get going, and then, tweak and prepare. So in this case, we're actually doing deep learning, because why not? It's MATLAB basics. Why not just hit the ground running, so to speak? But that's the beauty of being able to use these examples and just get started, right? And so also in the spirit of getting started, we're using a pre-trained network that came from wherever. In this case, we'll use GooglyNet, because it's Google, and it's LeeNet, and that's cute. But you know, this is really a practical thing to do. So you don't always have to start from scratch. I think that's kind of the bottom line here. You know, you can start with an example, start with a pre-trained model, start with, you know, something that someone else has already done. You don't need to start from scratch.
And you don't have to have a deep understanding of these trained networks in order to do image processing.
Exactly. And if you want to have that deeper understanding, for example, you can use the apps. So I mentioned about the Deep Network Designer. You know, I loaded this in from GooglyNet. We loaded into MATLAB. But I can open up this app and really visualize the network and all the different properties, you know, make some adjustments, and then generate the code afterwards. And so really that's kind of the point of showing this. You know, we don't have to get into deep learning necessarily, although it's quite easy and fun in MATLAB. Oh wait, where's my start page? Here's my start page, very good. So here are some of the kind of visuals of what these networks look like.
Oh, wow.
Yeah, isn't that nice to get kind of a little bit of a heads up of, you know, this one's a bit more complicated than this one. You know, of course, sequence networks are much less complicated, but rich in their layers. And so, you know, you can start from there. Really, you know, dig in. You can see some of these layers that you could add and remove. And again, the point of showing this is just to kind of get experience with that sort of flow where, you know, we do a little coding, do some, you know, stuff in the app, do some visualizing. Let's see, let's zoom in here a bit.
Zoom,
right.
enhance.
Zoom, enhance, enhance, enhance. But you can see, you know, it gives you information about the layers. Most of the time you don't need to worry too much about it, but it gives you that information. You know, a lot of MATLAB users aren't quite just like, yeah, just go ahead, deep learn for me. No, you want to know what's going on. And so you can make adjustments, and then again, the idea is once you've done that in all of these apps, you know, it's going to be able to generate the code and export your network or your, you know, results basically to MATLAB. So that's kind of the quick and dirty, you know, deep network designer crash course, I guess.
So we're getting a question about, can we use MATLAB for embedded systems, or is it just for data analysis?
That is a great question. Probably a whole half of our company would be like, what? Like, why would you use it for data analysis? It's just for embedded systems. But yeah, there actually a lot of people use MATLAB for embedded systems because of that prototyping. You know, it's that kind of philosophy where, you know, get going quickly, you know, get your designs ready, test, and then, you know, you can actually just hit a button. And so, for example, if you go, this is my local desktop MATLAB that I've opened. And you can see, I guess I used this one recently. There's MATLAB Coder that will, you know, walk you through this process of, you know, taking your MATLAB code and making C code. There's GPU Coder that will do the same for CUDA. I don't think I have embedded coder installed because that's scary to me. But there's HDL coder, you know, the same kind of idea where, you know, people will use, we talked about Simulink, they did a live stream last week on that. So people will design these like very complicated systems for a vehicle or for an aerospace system, and then hit a couple buttons and get the embedded code. So that's extremely, extremely popular. Also, even you can see there's like production server compiler, web app compiler, you know, those also make it similarly easy to host your MATLAB code on the cloud, to make an app very easily with, you know, what you're already working on in MATLAB. So definitely lots of applications. I think especially many of us in school, it was like, oh yeah, MATLAB, like x equals blah, 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 blah. You know, but now it's, you know, it's good to know it's much more professional than that.
Yeah, and there's one person asking, what is MATLAB, which I feel like is a huge, super broad question, but I think it would be good to talk a little bit about different application areas that we can go into using MATLAB, that it's not just data analysis, even though that's sort of what we're focusing on today.
Yeah, definitely. What is it to you, Elsie? What is MATLAB to you?
Well, I tend to be focused very much on the data side, because data science was what I did in school. But I always like to talk about Simulink and modeling things. But you can see the wide variety of applications here.
And I think of it, you know, we probably, depending on who you ask, it's like, what is MATLAB? Like, well, it's a state of mind.
Maybe the real MATLAB was the friends we made along the way.
Exactly. Let's ask Cleve.
Yeah.
But, you know, basically it started out as a programming language for, you know, linear algebra. Basically, it was started by Cleve. He was linear algebra professor. And so that's why everything's a matrix. That's why it's really well designed for matrix algebra, linear algebra. And it turns out that's also how like deep learning works, and like all machine learning and everything is all kind of just linear algebra. So you know, it's really built from there. Also, you know, even though that's where it started, you know, people quickly realized that, you know, you could very easily do, well, the data analysis and simulations, controls, you know, those big kind of complicated, yeah, I guess the control systems. I don't know enough to talk about it probably well enough, but you know, these kinds of things where, you know, you're not only taking data, you're analyzing some kind of situation and then kicking in. For example, I was helping, maybe I shouldn't say the name of the customer. Never mind. I was helping someone with a situation where they wanted to see if there was like a pilot, if, you know, something was happening, if there was a medical emergency, then they would want some control system to kick in. And so it was this combination of, you know, some AI using, you know, eye tracking, and then controls to, you know, kind of have that flow of like, if this happens, then, you know, have the controls take over. So I think of it as pretty much anything with math is MATLAB.
And math is all around us.
Math is all around us. But yeah, that's it. You know, because it's so versatile like that, you know, you could use it for lots of things. But, you know, generally speaking, the historical uses are more like engineering, you know, embedded systems, like we're talking about, kind of that. It's quite good at that, you know, near real-time simulation. So, you know, you'll see that a lot too.
So we're also getting some questions about, other than, you know, going through the examples on the doc page, are there any kind of MATLAB courses that I could use to get started, watch the YouTube videos, but what's next?
That's a great question. Also, I should, you know, I was a trainer, I was a training engineer for like the first 3 years I worked for MathWorks, so I shouldn't just minimize it to like, just find an example, you're fine. No, there are quite good resources for this. Actually, I'll even show it since we're here. Oh geez, wait, I think it's just MATLAB Academy. Yeah, if you search for MATLAB Academy,
There we go.
you can see that I clearly have completed 4% of the signal processing on-ramp. I'm well on my way, I think.
Yes.
So the on-ramps are free. Generally, if you have a university license, all of these things are free, but you can find, you know, on-ramp is like a 2-hour, you know, quick start kind of thing. You know, the MATLAB on-ramp, of course, that's going to teach you about the language. You know, some of those things we were talking about, like what is a vector, or how do you do math. Of course, you know, my friends, 6%. Now, to be fair, I did do like a whole PhD in machine learning, so it's fine. I'm fine with only having 6% completed. But you know, those are free. That'll give you the MATLAB experience and the domain experience too. So like the signal processing, image processing, you know, so you can find all of that. And then there are much more extensive courses. You notice the on-ramp is 2 hours, and then there's like a more extensive course that's, you know, more in depth, basically. So those are great spots to get started. what else? We have the Coursera course. I mean, it's a data science one,
Yeah.
but there are a couple nice courses on Coursera too that are free that you can, get access to MATLAB, try things out, and really kind of ramp up your skills in data science and in MATLAB at the same time. All right.
So we're getting questions about applications of MATLAB in real-world industries. I'm seeing a specific ask about NASA in the chat.
Oh, very nice. That was the one I wasn't going to talk about.
Oh no!
No, it's fine. I think we can actually, let's
Bust
see.
in the doors. And
I know.
the stream will cut out.
I was in California a couple weeks ago doing university stuff, and my colleague worked for he does a lot of government visits, and so he would be like, "Well, I work for the government, or I go help them with math." I'm like,
yeah.
"Shh, don't say anything." So that we can't talk about, but user stories are a good place to see what is possible. I like have you ever driven a car or rode in a car?
I have both driven a car and rode in a car.
You probably saw some MATLAB and Simulink then. Cool. So literally every car probably has, in some capacity, has Simulink, MATLAB in there, exactly for that reason, the embedded coding. Yeah, you've heard of NASA, probably.
Yeah, once or twice.
That Mars rover thing that
Curiosity?
Matt Damon. Oh wait, what? Yeah, one of them. I think that's the one.
Yeah.
Yeah, that's MATLAB. There's a lot of MATLAB in there too, and Simulink. Again, the vehicle kind of stuff. There one I guess I worked on was for Shell. They were doing some machine learning stuff. Here we go. Searching all the user stories. So this kind of gives you an idea of what people are doing, what kind of real world, so to speak, applications. I think I have a talk that I call research versus reality. So I think that's one of the nice things where you have people that are doing tons of research on this, but not necessarily thinking about that next step, where hey, I'm Airbus, I need to automatically detect defects in pipes while we're manufacturing, or figure out where to safely land. So those are some of the examples that I think of. A couple others. I was trying to find the one with it was farming, basically mapping land. What kind of it's basically climate change type stuff, right? Land map. I can't think of the words now. I'm talking too much. But seeing the forest and seeing the forest through the leaves or whatever. But measuring that over time, or deciding if they need to water that or seed it differently.
And that's a great example of an image processing problem having a very defined real world application.
Exactly. Yep, and even we see a lot of, we talked about automotive, but automated driving kind of stuff and robotics, those kinds of things, because you can test and simulate and use all of those different tools, including image or LiDAR or whatever, get it pretty real time so that you can actually have that running on the device. Awesome, I love it. Any other questions?
Seeing any?
All right.
We can move on to the
audio
next.
toolbox. Oh, that's boring. Engine sounds.
Oh, do we have any examples of predictive modeling?
Yes, of course, absolutely. So there are quite a few different types of predictive modeling. I'll go back to the apps tab here to show. So I guess it depends on what your data look like. I think of predictive modeling as sort of the squiggly, squiggly time series data. I'm sure everyone's really proud of me. Now, I do have a PhD in math and stuff. But squiggly time series data that you want to do a forecast, right?
Yeah.
So that in that case, you have econometrics where you could do, this is ARIMA, GARCH, those kind of proper time series modeling. Also, same with the signal analysis, depending on maybe you want to model or, use the squiggliness of the signal to, analyze or predict in the future. So you can use that. And then, of course, the regression learner, that would be, predicting sort of numeric forecasting, but then curve fitting also. So those are kind of those, regular types of things. But then, of course, we have machine learning and classification learner, regression learner. Classification is more like predicting a label, right? Good, bad, hazardous. I don't know, really, really bad, and really, really good. So, it really kind of depends on what type of predictive modeling you want to get into. Same for deep networks, deep learning, we showed that, reinforcement learning, so quite a lot of prediction options, I guess, based on your application. So, yeah, good one. Quite good at predictive modeling since 1984. All right. What was I going to do? Why was I here?
We were looking at the image classification example, but we could look at something else.
We were. Okay.
We could look at quirks of the language.
Okay, let's do that. Intro MATLAB. All right, I think my brain is starting to break down. So that's okay. It's about that time. So I wanted to mention, even bringing in data, right?
Yeah.
We saw just making stuff up, like 1:100. But I just clicked on this. I navigated to the directory, double-clicked, and this is the import tool. Cool. Yeah, let's import that. Easy. And, again, kind of that philosophy that we were talking about, we can generate a function, generate a script that will let us do this over and over again. So, I can just call this the next time I want to import the same kind of file that has the same kind of organization, and it gives me all of that code. Most of it's unnecessary. You really just need this one right here. It'll find.
Those things do things like give titles to the table and whatnot. So it's helpful.
It's helpful, yeah. But don't be afraid. If you really wanted to read it, you could just type read table and it probably would work. But this is quite nice. You can even change the way that the data are represented. Actually, I guess we should probably change that to a regular date.
Yeah, it's editing it the same way you would in Excel. Then it keeps your edits when it generates the code.
Excellent. All right, now I'm going to spend the rest of my life trying to find the representation of this, so never mind. We'll bring it back in as text. All right, so again, kind of that same philosophy. Let's just take a look at what we would do if we want to, let's say we just want like the first few lines here. Mm-hmm. So we can right click. I just opened this up in the variable editor, and I can decide whether I want a new table or just a new, each one to be a separate variable. And if I want a new little table, notice it's indexing for me. So it's showing, again, you kind of that reinforcement of I did something, interactively. It's also giving me the code. And it gives you a sense of how to index, right? So let me do that. So for example, I just selected that one. So that's the first row, fourth column. The nice thing too with tables, I can use the name. So you could also do something like that. Very cool. So it is still a table. So that's one of the things, I guess we called it quirks of the language. Generally we have a matrix or, a numeric data, right? So let's say we have a magic matrix, because I always like magic ones. Do you know why it's magical?
Why is it magical? I've never seen this function before.
It's magical. So the sum is equal in every direction, even along the diagonal.
That is magical.
Yeah, very magical. But also is just like a nice example whenever I'm trying to show indexing, because it has different numbers. So if I wanted to get that one, I would do first row, second column. Excellent. So then we saw there was like a colon operator. We showed that earlier. It's like 1:100. Let's say we wanted to get the whole second column, that whole thing right there. So we could do, all right, let's work our way up. Let's get the first 3. Oops, that's the other way. It's all right, that shows you, we're all learning. There we go. All right, so I want the first 3 rows of the first column. Sure, let's just do that. Sounds great. Then if I want all of them, I could do like 1:5. But if I know I want all of them, I can just also use colon. So that's a nice shortcut. So you'll see that a lot in examples and other people's MATLAB code where the colon basically is 1 through end, or 1 through all.
And if we were doing it in a table, could we say just pull the column labeled grade?
Yes, exactly. And so that's one of the tricky things, or not tricky, but something to keep in mind with tables, right?
But what did you just do there when you typed home?
Oh, very good. So home, that just made my cursor go to the top of the command window.
Cool.
And if I typed CLC, it would erase the command window, but I might want to scroll back up. So I just went home. Phono. So yeah, if I go back to our table, something like that, right? Yeah. But notice again, that's a table, right? So if I actually wanted all of that, I could say, whatever that is, dot grade. And so that brings the whole column out, and it also uses the data type underlying. And so that's one of the things to keep in mind, whenever we're just showing a matrix, that's one consistent data type. It's rectangular, it's a matrix. Whenever it comes to a table, you can have all different kinds of data types. So, it's a container. This is also true for a cell array, a structure array, a couple other MATLAB types where, we don't know if you want to make a new subtable or if you actually want the data inside of that. And so whenever you're using the dot notation, that's going to give you whatever data is in there in whatever type it is. And if, so sorry, I was like, wait, what did I want to say here? But generally, parentheses in MATLAB, whenever you use parentheses for indexing, it always retains that initial data type. So if I use parentheses to index into a table, I get a table. If I use it to index into, strings, I get a string. And then, with tables, you can do the dot notation or also curly brackets. Curly for content. So. Oops. All right, I wanted more than that. So similar, but again, that's one of the ways. It's another curly for content that's kind of going to get into that array and bring it out as whatever type. What else do we have as...
So does the curly braces do the exact same thing as the dot notation, or is it slightly different?
It's slightly different only because you can do multiple, like the curly brackets are akin to, let's say, like a matrix, let's say 5 and 6. Let's say we want both latitude and longitude. So with the dot notation, you're usually doing like one column or one field at a time. Curly brackets, you can kind of subset almost like you would with parentheses. You just have to be careful that it's going to have the right data type. So for example, that's going to error because I'm getting strings and categories and I'm trying to pull it out into the same data type. Make sense?
That makes sense.
All right. Doesn't always make sense.
So we have people in the audience looking for technical assistance available in the MATLAB community, and I think we have a couple of different options for assistance.
Definitely. Let's go back here. So actually, if you go to the MathWorks page, there's support. So you can take advantage of, well, obviously there's actually tech support requests that you could put in. But if you go to the MATLAB community, this is a wonderful place to go to get started. There are MATLAB answers. Some of us, I don't know about you, but we get bored at work and this counts as work. So we'll just go to MATLAB answers and see what we can help with. Also, you'll find a lot of examples on File Exchange. These are also linked to GitHub. so that's one great place. You can just, type it in. Most likely some super smart person is going to figure it out. And then also, again, if it's something like setups, oops, oh geez, what am I doing now? I'm just clicking on things, I'm losing my mind. The tech support request. Why was I? Yeah, anyway, you can find that. There's also, at the end of each doc page, there's like, help us help you. So there's lots and lots of ways to get help and get started, even just, social media, hit us up on Instagram or whatever. We're very happy to help.
All right, so we also have some questions about how do I overcome the fear of getting into coding?
Be brave. I think I believe in you. But I think that's a really common question, or really common kind of, a thought of, people are like, oh, I have to learn how to code. I have to learn how to code. I mean, you'll get the hang of it. Using these kinds of things, like taking advantage of, oh, hey, let's make a new workspace variable. Oh, that's how I use the syntax. Those are really the ways to, I think, get more confident. And of course, using examples, that's just reality. You think of people that, are really good at coding. They're really good at copying and pasting, right? That's all there is to it. I'm good at like reading doc.
Yeah. I think it's like the biggest thing to know is that people who know how to code, there's a lot of posturing. I personally found the MATLAB on-ramp to be very helpful as far as building confidence, partly because it's self-paced, so if there's something that's tripping you up, you can just spend more time working on it. But yeah, the great thing about MATLAB is you can code when you want to, or use the UI, and you can generate code. So if you're not completely sure how to do something, you can do it in the UI, pull out the code, and now you know how to code it.
Exactly. And then that kind of helps with the things that are, tedious, I guess. And I guess the other thing, you're gonna make mistakes. It's sort of one of the fears, like, oh gosh, I'm gonna screw this up. Like, definitely. I just pretty sure I brought down an entire university server this morning, but it was okay.
And also, never be afraid to Google things. I feel like I regularly have to Google basic concepts because it's just flown out of my head.
Yeah, absolutely. Linux is ashamed of me because I have to chmod, unless it's 7777, I gotta look it up every time. So, I think that's just the reality of it. Just the more you practice, the more you try things, the more confident you'll be. And, you definitely can do it. This is the perfect way to get started.
So we have a question about how to analyze turbulent flow using MATLAB. And I'm also wondering what turbulent flow is.
All right, let's see. How to analyze turbulent flow. Aerospace block set. Excellent. So that's literally what I would try to do. I would just see if there's anything already in here. Oh, a book. Here we go. Perfect. More turbulent fluid flow. So this is, of course, maybe you don't want, obviously we're not going to cover this in the next 5 minutes. Yeah. But clearly there's a lot out there. And, even this is, if you want RAN's version of it, RANS, I barely know what I'm talking about. You can see what other people have done. Maybe they wrote a paper about that and they're sharing it on File Exchange. So that is one of the best ways to go. I'll say, depending on what you're trying to do with it, you might want to do physical modeling, or you might want to do something like partial differential equations. For example, where's my live script? Sorry. There's a live task for optimization. What was I just talking about?
Different
PDEs. There it is. There it is. Yeah. So, if you look at the PDE toolbox, there's a good few examples of. Yeah, this is not very compelling. Sorry, I should have had something ready.
Well, we don't have any PDEs to look at here, so it
exactly.
makes it hard to import and view the results.
Yes, indeed. But that was a pretty cute icon, I think.
Yeah.
But anyway, those are some good places to look.
So are there any resources for someone transitioning from using Excel to using MATLAB?
I actually believe there is a webinar, like MATLAB for Excel users. There
Yeah,
are
and
a
I think
couple
we also
of
have some videos,
Yeah.
especially for things like importing data from Excel. But as we showed earlier, you can open up your data set in the data importer tool, and it works very similar to Excel as far as how do you change the way the data is formatted, making sure that it's the right data types. And then if there are
Exactly.
specific Excel functions that you're looking for, just look them up in the documentation. It probably is called a similar thing in MATLAB.
Yeah, and I think it's great because, especially if you're used to Excel, it's similar. It's the name of the function, parentheses, name of what you're trying to apply the function to, right? So you'll really be, I think you'll be very well suited to learning MATLAB quickly. Definitely take advantage of the videos. I think Elsie even created one.
Again, it's like the learning how to code thing. We have this idea that coding is this big, scary thing, but really the jump from Excel to MATLAB isn't that big.
Exactly. And, that's that's the beauty of it. You can try stuff, use examples, use the apps, and get used to it. That's kind of the philosophy that we were talking about. I think we covered pretty much everything.
Yeah.
Not too bad. So, lots of resources for getting started. We'll, I'm sure I guess we shared some links so far, but basically the documentation is a great place. And the MATLAB Academy talked about that kind of, fundamental, it's math, it works, math works.
Yeah.
It's all matrices, things to keep in mind. Starts at 1, not 0, like other languages you might be used to. I guess I forgot to mention that.
Well, we showed it.
We did.
Yeah.
You're right. 1:100. And we went through some indexing, and we can, again, point you to any resources. Any other questions we have?
Well, we have a question about, the person caveats that this is slightly off topic, but can you tell us a little bit about Simulink, just in general, what's Simulink?
Sure. Also a state of mind.
Yeah.
So it's a platform for simulating oftentimes, physical systems, right? So if you want to, I don't know, I always think of the pump, there's like this pump example where, it has sensors and, you don't want to break the pump. You want to try to, model how long you have remaining useful life, something like that. You can use Simulink to simulate the data with different conditions, and then you don't have to break the pump. Then you can actually, put that Simulink code onto a device, just like somebody had asked earlier about embedded coding. And so I think we have another live stream coming up, right?
We also have one from a couple of weeks ago.
Yeah, that's right.
But I think we have some Simulink toolboxes that are going to have live streams coming up. And similar to the way that there is a MATLAB on-ramp, there's also a Simulink on-ramp.
Yeah, definitely. Yeah, so you should be able to find the Simulink BaseX live stream from a couple weeks ago. You should be able to find that in MATLAB YouTube. So, yeah, thanks everyone. This has been great. Thanks for this excellent questions. Hopefully you're more confident and ready to get started with MATLAB. And thank you. Thanks, Elsie.
Thank you, Heather.